on this computer. So let's begin, guys. I think it's recording. I think it's showing the proper page. It says here, the time Rafa spends on his homework each day in a term time has normal distribution with a mean of 1.9 hours and a standard deviation of sigma hours. So I'm going to go ahead and in that sentence, I would automatically just draw this and I would put a mean here of 1.9 hours. And then it said, so these are your X's and their hours. And it says sigma hours, you know, whatever. We don't know what sigma is actually. So I'll just go ahead, quote question mark. And it says on 80% of these days, he spends more than 1.35 hours on his homework. So here's how I would depict that. So 1.35 is like, let me change the color. 1.35 is this. And more than, like on 80% of these days, he spends more than 1.35 hours. So this is more than like this. And this area here would represent 0.8000. Now part I says, find sigma. So what should we do first? What do we need? We would need to have a z-score that corresponds to an area to the right of 0.8. Now, what I want you to realize is that if we found the area to the left, that's 0.8000, this z-score, if we found this, then we would have found the positive version of that one because that one's a negative z-score. Does that make sense? And the table we have only reads positive z-scores, areas to the left. Does that make sense what I just indicated? The z-score that will correspond to that area to the right of 0.8, which is a negative z-score, is equivalent to a positive z-score, area to the left. Because that's all we got. So we go to our table. That's obviously the first step, figuring out that z-score. So I'm going to go to my table in the book because I ran out of tables. It's somewhere here in the back. Somewhere. I think it is there. Where is it? There it is. I found it. So I'm going to go ahead and identify 0.8 something. So we got the closest one. We got the closest one to 2 decimal places. 0.84 is 0.7995. If we added 5 to that, if we add 0.0005, it says here to add 0.002 to this. That's what it means up there. So I should maybe separate that a bit because everything's bunched up. But for a z-score of a z-score of 0.842, you'll ride to an area of 0.8000. So this here, this z-score here is 0.842. So therefore, this guy here can be represented as negative 0.842. Do we understand this? If you don't, yes. Okay, so did you see 0.7995? And it was 0.84, right? Well, you see the z-score on the left, the vertical column, it says 0.8 all the way to the left. And then if you drag your finger to the right and you run into 0.7795, do you see the number all the way to the top as a 4? There, because the next one is 0.8023. That's too far out. But now, if I just added 0.0005 to 0.7995, wouldn't I be at 0.8000? Now, if you go all the way to the right on that same column, on the same row. So it says, there you go. There. See it? Okay.
So to order to hit 0.5, so you added 0.02 in order to make it 8. Because if you look at the chart, the 2 here, then it would get 5. You would get 0.8.
I didn't understand.
And that's negative 2.
But you understand it now?
Wait,
I didn't know you had to like
Huh?
find one that's close to it. I thought it had to be the exact number and I couldn't find it.
Okay, so in this case, usually we would just pick the closest one, which would be 8.84, but since we have that accuracy that we can go up and get closer, then we can do that additional decimal place. Yes.
Why didn't you, because on the other one, like on the last one we did, you subtracted it by 1.
Okay, in this case, I didn't have to worry about that. Okay, it just depends on the situation. It depends on the situation completely. Like our table will only read from z equals 0 like this. And it will just a z1. I don't have z2. It only reads this way. So what happens is it only reads from 0 on, and it's always like this, getting bigger and bigger and bigger. Occasionally, I'm going to ask you, or you're going to get a question where it says, hey, what about this one? Well, we can't ever decipher that one. So what we do is you do 1 minus that to get this piece here, and now we would know what this is. I'll give you an example. Very simple. Let's just do it with real numbers.
Wait, so if you're trying to find the majority, then you don't do the subtract by 1?
Okay, so let's say I did this. And I said this was 0.800. Oh, sorry. 0.2004. Can you find the z-score associated with that? From that table? Is that going to be a positive score or negative z-score?
Positive.
Well, no.
Oh, because it's behind.
Yeah, so it's positives are going to be over here, negatives are going to be over here. So it's a negative z-score. Does your chart tell you negative z-scores?
No.
No. But if you look at this situation is also modeled by this area here being 0.2005. In other words, if I found this z-score for this here, then I would just make it negative to have this one, right?
Yeah.
But if I take 1 minus this, it's 0.7995. And what's 0.7995? 0.84. So then this one has to be negative 0.84. Does that make sense?
Yeah.
So it depends on the situation. Are we clear with that? I'm trying my best. Okay, so now let's get to the nitty gritty here. And I really should make more space for this because I'm running out of space. So I'm gonna use the magic. Nobody's using a Windows Surface laptop. Huh? Who's the teacher? Oh, damn. Nobody else has been inspired to use it?
No.
You guys haven't told them what a fabulous tool this is?
Here we go. You can tell them, but when they see the price, they know.
Oh. Look what I just done. Look at this. Come on. Come on, do it.
Do anything.
Watch. Come on. You saw that?
So,
You didn't see a
I
shift
saw a glitch.
to the left.
That's it. Fine.
I shifted to the left, bro. Don't you see it? You didn't see I shifted the whole thing to the left?
No.
Now I see it.
This,
Yes. Can you connect to an Ethernet cable?
if I had an adapter, yeah.
They have it for the apples?
Yeah.
Made by Apple or made by a third party?
But, or they would have the Apple, they would make their market, so. the Apple.
Have you seen the one that like for the new phones where it's like like earphones and the other one for two? So in red, so.
Listen, I have an iPad Air and every time I've used it for class in the past, I hate the whole experience. I hate
Why do
it.
you have so much money just like to buy so much technology? You should make a channel and just review all of it.
I'll be a horrible reviewer. All right, let's do I because we haven't done anything. Have you noticed? We just like, look. So here's the thing. We want to find sigma. Remember, what does z equal to? X minus mu divided by sigma. So sigma equals x minus mu divided by z. So what is x gonna be? What is x? Your x is 1.35. What is your mean? 1.9. What is your sigma? Negative 0.842. So let me go ahead and pull out my calculator here. Hopefully I don't make mistakes. 1.35 minus 1.9 equals negative 0.55. And divide that by, or yes. Go ahead. There must be, yes.
So this page is hosting a blood donation drive. If anyone's interested in getting community hours, you gotta be 17 or older.
Anybody interested? You got any blood?
Raise your hand.
No?
No?
No, my internet's
Thank you.
superior.
Take care. So that's the answer you get.
I like that. Like that.
Did you see I? Can you understand I now?
I didn't get my internet's.
Do you understand what I did there? Guys, you
It
could,
would be no, just kidding. No, I'm not. Would it be negative?
no, because negative divided by negative is a positive.
Oh, okay.
Guys, standard deviation has to always come out positive.
And that's the answer?
That's the answer for part I. We got the negative 0.842 from our standard deviation. I mean, our z-score. Our part 2 says, find a probability that on a randomly chosen day in term time, Rafa spends less than 2 hours on his homework. It's, I guess in England, they call it term time, like when they have those tests, the tests like we do, like, I don't know. So here we have 1.9s in the middle, right? And what's our sigma gonna be? 0.653. Now I've kept it in memory. I actually feel more comfortable writing a few decimal places more. 207. So I'm gonna write 207 just to keep a little bit more accuracy, but it's not necessary. Now 2 is here. Somewhere here. This is not to scale. Whatever. These are x's. This is your mean. This is an x. And it says there, spends less than 2 hours. So we spend less than 2 hours on our homework is this situation. So what do we do? How do we get that area? What do we need to do first? We got to convert what? The x into a z-score. So let's go ahead and do it. So your z-score here, and let me go ahead and try to make this as organized as I can. And Z-score equals 2 minus 1.9 divided by 0.653. Yes. So we have 2 minus 1.9. That's 0.1. And then we divide it by 0.653207. That's 0.153. We got to go 3 decimal places. So 0.153. We go 3 decimal places because our table allows us up to 3 decimal place accuracy. So now all you have to do is remember, I guess I'll write it nicely here. The probability of X being less than or equal to 2. Let me read the question, make sure it's less than or equal to. It's just as less, so less than 2 equals just fees of 0.153.
And I like find that.
Then you just go to your table and you just look up 0.153. So 0.15 point. So 0.15 gives you 0.1. So I'll just make sure I write everything. A z-score 0.15 gives you 0.5596, but we want 5.3. If you look at 3 all the way over there, because you must add, so if the z equals 0.153, you have to add to this 0.0012. So that comes out to 8, 10, carry the 165.5608. So this area here is represented by that. So therefore, the probability of X being less than 2 will be 0.5608 according to my calculations. Whose office? Are you okay? Only if you are,
Oh, try to be.
please, careful. All right, so part C, let's take a look at part C, which I don't think you can see anymore. So part C here says a random sample of 200-day interim time is taken. Use approximation to find the probability of the number of days on which Rafa spends more than 1.3 hours on his homework is between 163 and 173 inclusive. Now, in theory, when you took a look at the answer key here, it started talking about a binomial distribution. So I want to go ahead and I haven't taught you this, but I guess what this question kind of presented to you guys. So a random sample of n equals to 200. And use an approximation to find the probability of the number of days Rafa spends more than 1.35 hours on his homework is between 163 and 173 inclusive. So we have 200 days. We have 1.35. So we want the probability that the days, I can just use, I don't know, D. I should use X. Let's just agree X means days. Oh. So the probability, now I can't see the question. That's why I just kept the question up there. So let me just slide back and forth here because it's easier for me. So it says, probability that X is between 163 and 173 inclusive. Wait. 163 and 173. So 173 goes on this side. And 163 goes on this side. Now, what was the probability that we got earlier in the question for the probability of spending more than 1.35 hours? What was the probability we got at the beginning of the question? The probability of the time greater than or equal to 1.35. At the beginning of the question, we got is 0.8000. Do we agree? Now, we've switched from hours to days, right? In other words, we want to know the number of days, what's the probability of the number of days he spends studying more than 163 days to 173 days. That's what we want to do. So the question is this normal? And the answer is, it's actually not normal. We got to prove it. We got to say, and actually, this type of question is binomial. Because the probability he'd be successful, in this case successful, of studying more than 1.35 hours is 0.8 of the time. And Q will be 0.2 or 1 minus P. I guess we're going to stick to 1 minus P. This is success. This is failure. Now we have a fixed number of trials, which is N. N equals 200. I'll put 2,000, which is the fixed amount of trials. And the probability stays the same. It's consistent. We can assume that. There's independence between each of the trials. And we have 200 days. So the first thing we do is we check to see that if N times P is greater than 5. Now, let me just make sure that this book keeps the same standard. I think they do. Well, it could be 10. What happens is if you model these binomial distributions, as the combination between N and P grows, the shape of the distribution becomes normal. And so we want to determine, first of all, if indeed that's the case. They're using 5. They want to say if N times P and N times Q, which by the way, Q is this, is greater than 5. If those two conditions are met, I can approximate this binomial distribution. So this, I guess this X as a binomial distribution with an N of 200 and a P of 0.8. So this is N and P to a normal distribution. And this normal distribution will have a mean of N times P and a sigma of the square root of N times P times Q. Now, once I determine that, which I'm going to do just now, your mean is going to be 200 times 0.8. And your sigma is going to equal to the square root of 200 times 0.8 times 0.2. That's what you got. I really should get my calculator for this. Oh. still have to do the other question too. And I'm still recording. So we got 200 times 0.8. That's 160. So my mean is 160 days, right? And my sigma is 200 times 0.8 times 0.2, and then take the square root of that answer. And I'm going to go ahead and write this to 3 decimal places. 5.657. I'm going to keep it in the memory of my calculator. That means that this binomial distribution can be represented approximately by a normal distribution with a mean of 160 and a standard deviation of 5.657. I'm going to keep it in memory so I can use more accurate numbers. And we want to know the probability between 163 and 173. Remember, these are x's. Oh man, that's really close. I don't like it. D stands for x's. These are days. We want this area. So now, there's a little bit more technicality to this. It's called the correction factor. But let's just stay on this right now. So in theory, z-score is 173 minus 160 divided by 5.657. And z equals 163 minus 160 divided by 5.657. And so it's 173 minus 160 divided by 5.657. So this comes out to 3 decimal places. 2.298. And the other one, 163 minus 160 divided by 5.657. So that comes out to 0.530. Now, what do you think we do next? And if you come here, I want to make sure I have the same z's. 2.386. I can't even remember what I used. Okay, so I didn't get 2.386. Why did I get 2.836? All right, so my numbers are off according to theirs. So let me make sure. I don't want to give you bad notes. Oh man, was n 160? No, n is 200. Okay. So 160. Okay, so they instituted the finite correction factor. So here's what I want to talk about. My answer is slightly different than theirs. And here's what happens. So, yeah, this is important. So I decided not to use 162.5 because I'm teaching you this, but it makes a big difference in the answer. The reason is because a binomial distribution is a discrete probability type of distribution. It's not continuous. So and therefore, if you were actually, come on. Yeah. Sorry. Always. All right, guys. Sorry about that. So there's gonna be like 10 minutes or more lost there. Okay, so so here's what happens with the explanation to that. Guys, if you were to actually have dealt with the original binomial distribution, it would actually do this. It would look like bars like this. And there'll be many bars. In fact, there'll be 173 minus 63 is 10. There'll be 11 bars there. And what happens is that this curve, as it goes here, is ignoring these pieces here. Because it's just an approximation. So what we do, and notice what they did. When they got here, instead of using 163 and 173, they use 162.5, half over, and they went 173.5, half to the right. Now, no, you open it a little bit more. Now, that to make up for that loss. It's still an approximation though. But now they said any of 162.5 because there's two ways of doing it. I like opening it up. There's a few ways to do it. There's a few methods, but it doesn't matter. So instead, you make this 162.5, and then you make this 173.5. And that's you're correcting for the fact that you're using a continuous probability distribution, a normal distribution, to approximate a discrete probability distribution. That's a binomial distribution. So now all that does is it changes these two numbers, and it makes a difference. Now, if you wouldn't have done this, if you would have forgotten on the test, you still would have gotten points, but it would have been a shame to have lost those points. Okay. So there we have it. Let me go ahead and correct those guys. So we have 173.5 minus 160 divided by, I do have it in memory, so let me go ahead and not be lazy. I have it in memory. Square root of that, and it comes out, oh my gosh, really? 13.5 divided by this. We have 2.39. No, 386. Remember, we got 3 decimal places. And 162.5 minus 160, but divide that by the square root of 32. And that comes out to 0.442. And so now all we got to do now is go to our table. 2.386. 2.386. So we look up 2.38. We get 0.9913. So 0.9913, but we have to now add 0.0002. So it's gonna be 0.9915. And then the other one, if we look up, that's a really good bad spot to put it in. Oh no. If we look up 0.442, so 0.44 is 0.6628. And then we have to add 7 to it, so it's 0.6635. And now to get the area in between, you would have to subtract them. In other words, the probability that X is between 173 but greater than 163. Okay. Now I'm going to go ahead and leave it without the correction factor, the correction that you need to make for it to make it a little bit to get the missing area. Is equal to essentially fees of 2.386 minus fee of 0.442. And so that's just going to be 0.6685, 0.9915 minus 0.6635. And if we did that, we're gonna get the answer. And my watch is telling me to stand up, but I already stood up. And guys, you didn't work out this morning?
I'm starving.
Well, I'm starving too.
You should eat
Well, why would I eat?
because your body needs fuel.
I'm still alive.
What?
I'm still alive.
But are you happy right now?
I think happiness is an illusion.
Oh, boy. Great. Can I go next door to get food?
Yes, go next door to get food. All right, guys. Is number 7 explained thoroughly enough for you?
I saw the quick five thing, and I was like, and it reminded me of when we did the bars, like that thing, but I didn't.
You didn't put it together, but that's what it is. What's happening is since we're using a normal distribution to approximate a binomial. Does that make sense to do nowadays with technology? The answer is no. Like in the past, you had charts that would give you these areas with binomial distributions, but they weren't like, they had certain amount of sizes, n's and p's associated with it, successes. So when you got something off, you just said, okay, let me just approximate it using a normal distribution. But nowadays, you go to calculator, you go binomial CDF, and you put left and right, and here's n and here's p, and boom, you get the answer. There's no reason to do that nowadays. But it's interesting to notice that a binomial distribution, as n and p relate to each other, if it's sufficiently large, it becomes approximately normal. Well, you can approximate a normal distribution to a binomial distribution, and that's amazing. Any other questions? Now that you've come, what about the other one? Were you guys able to get the other one?
But then I realized I got the wrong answer, but I don't know what I did wrong. Because I didn't read it right.
Okay, so you got halfway through the answer, but then, okay, so
I answered the first one and then I got it wrong. But
yes.
I did it the right way. So yes, very confused as to why.
Okay, so let's take a look at number 5 together. And so this video is going to be extra long with a moment of pause, and I'll try to edit that out so that you're not, huh? I will try. Yes, be careful. I should use the restroom too. I'm gonna go pee. Let me take a bathroom break. It's like 30 seconds. Well, with the walk is a little bit more, but let me go ahead and just pause this for a second. And if you guys gotta quickly use the restroom, please, by all means. Okay, so it says here, when Moses makes a phone call, the amount of time that the call takes has a normal distribution with 6.5 minutes and a standard deviation of 1.76. So what's the first thing we should do here? Once we've read that, we should draw a normal, a bell shape. And our mean is going to be 6.5. And our standard deviation is going to be 1.76. Do we agree? Okay. Now, I is the first part of the question we got to interpret. It says 90% of Moses' calls takes longer than T minutes. So look, you see this T here? Longer time is this time. Would that be a good representative of that? Would that T be there? Would this area represent 0.90?
0.90, no.
No. So where would you put that T if you wanted to represent 0.90?
The other side.
Yes, and that's good. So now you know it's going to be less than 6.5 minutes, right? It's going to be somewhere over here, but it represents this area here that collectively is 0.9 of the area, 0.900. I should really do that in another color. 0.9000. They want you to find the value T. So the first thing you would do here is you would need to relate that T to an appropriate Z-score. You know it's going to be a negative Z-score. You know it's going to be a negative Z-score. So what you do is you find a positive version of that that has an area of 0.9000. Agreed? Okay, so let's do that. So let's look for 0.9000. There's no such thing as exactly 0.900. Yet if you look up 1.28, 1.28 gives you 0.8997. It's close. Now, if we just had 3 more added to it, we would be good. But we don't. We can add 004 to it and we will be over it, or we just add 0.0002 to it and be just slightly under. I'm going to choose to be slightly under. So in other words, 1.281, we have to add 0.0002 to it. So that comes out to 9998. This is pretty darn close. So the z-score associated with a t there would be actually negative 1.281. So the z-score we want here, is negative 1.281. Now we're trying to find the value of t, and we realize that if z equals x minus mu divided by sigma, this guy here is x is the role of t. So if you want, we could say the score t minus mu divided by sigma. Oh no. It just zoomed out and then I scratched everything. So now I'm going to solve for t, right? Z sigma equals t minus mu. T equals. Okay, that's fine. But if you look at the mark scheme, this is part 1, right? Still part 1. Standardizing, no CC, 1.28 C plus or minus 0.1. They give you some wiggle room. But it doesn't matter because nobody can say that you don't know what you're doing. If they're complaining about a decimal place here or there, it's like you're not getting to the source of understanding. Some people might say it's better to overestimate it, right? I say, this is phone calls. I don't know. Maybe I don't want to overestimate that. Maybe I want to underestimate that, depending if these calls cost money. Nowadays, we don't spend that much money on calls. It's incredible how we come a long way. All right, so T equals 6.5 plus 1.281 or 2 times sigma. And that's 1.76. So is that pretty easy, guys? Yes. Okay. What was the area for 1.28? The z-score here for 1.28, what was the area in your table? All right, which one do we want? We want 0.9000, right? Why do we want that? Or perfectly, yes. But in this case, we couldn't. We got to 1.281. The test mark says 1.282. It doesn't matter. To 1 or to 2? Look at the end. So look at 1.28 and put your finger on 0.8997. Now slide your finger to the right. At some point towards the end, you're going to see some individual numbers that has like 1 or 2. You see that? They're alone by themselves, all the way to the right. Yeah, those. Do you see at the top? It has like a 1, a 2, a 3, like that. That's how you get the other one. Notice that if you pick 2, it's for the one up top. If you pick 3, which wasn't there, it was for the next one. It was for 2. That's how you get the answer. There's a pattern. Start your finger in the upper left-hand corner. Can you tell me the first one that's there? Now start sliding your finger to the right. What do you notice? It's increasing. Now, as you slide your finger to the right, and then you start again at the next column or the next row, right? It's getting bigger, 0.5 something, and it's 0.6, and it's 0.7, and it's 0.8. Oh, we're getting to 0.9. Oh, slow down, go back. Where's 0.8? 0.89. You see it? It's not random. You see it? So go, follow with your eyes. You see it? Oh my gosh, I'm gonna go over there right now. Give me 1 second. I'll be right there, Mama. Give me 1 second. I'm just calculating something here. 8.755. Oh, negative. Damn it. This is a negative z-score plus negative. I'll be right there. Let me check something. Okay, so.
Oh, wait, I have a question. So in 1.29, and 0.9.
It's too far.
We can't subtract.
No, we don't have it set up.
Yeah.
We don't have it set up for subtracting. But it would be nice though, but they have to make a chart. Okay, so you gotta be careful. Look, I forgot to put the sign there for my z-score and I was gonna miscalculate, but I noticed it immediately. 6.5 plus negative 1.281 times 1.76 parentheses. And we have 4.25 minutes. Now, it's instructive to take a look at the answer for the for this here. They got 4.24. Okay, they got 4.24. They use 1.76 for a standard deviation, but they still enter 1.24. I'm thinking that's because I used I don't know. Did I use it right? I don't know.
I went over and I got minus.
Yeah, but look,
It's the same.
okay, you see what I'm saying? Like, are you showing that you have an understanding of how to get these things and why they work that way? That's what they're looking for. Of course, they're looking for the numbers to be right as well. I mean, you're getting the numbers wrong, then look, if you understand how this is happening, the likelihood is that you know how to use your calculator and you can answer this question right. You're not gonna make those mistakes. If you're stuck understanding this, there's no way you're gonna get it. Now, at this point in your life, you gotta spend some time on it. All right, the next one says find a probability that in a random sample of 9 calls made by Moses, more than 7 take a time which is within 1 standard deviation of the mean. Now, I don't have space here. Okay. So the first thing we got to do is we got to figure out what 1 standard deviation from the mean means. And so this is actually a rather difficult question to put conceptually because you got to have practice it. Find a probability in a random sample of 9 calls. So this is mixing up a lot of things together. A lot of things together. Find a probability that in a random sample of 9 phone calls made by Moses, more than 7 take a time which is within 1 standard deviation from the mean. So here's what they want you to figure out. First of all, you need to figure out these 2 times here that are exactly at a z of 1 and a z of -1. That's the first step. And that's not funny because it's going to take you some time. But I mean, you have your Z though. The time is going to equal to mu plus Z sigma. You already know your mu, which is 6.5, plus 1 times 1.76. And then you have the other one, 6.5 plus -1 times 1.76. So now we end up with 2 times. So you have 6.5 plus 1.76. So we have 8.26 here. And then we have 6.5 minus 1.76. We have 4.74. Now, we got to figure out now the probability that's in here. So you got to take whatever you get here, figure out this piece here, and subtract it. So that's the next step. So a 1.00 z-score gives you a cumulative area of 0.8413. And if you do 1 minus that, did I do this question last class? I can swear I've done this question before. You get 0.1587 here. And now if you subtract these, the area in between is 0.8413 minus 0.1587. Yes.
You have to find the X.
Probably not. But I like finding them. 0.6826. So now we know the probability of being between those. Huh? 68% about. So now, guess what? So let's take a look at this here. That's how you get the first part there. Okay. Now the second part says the probability, and it says 8,9. And look at what it does. Okay. So let's think about it. It says, find the probability that in a random sample of 9 phone calls made by Moses, more than 7 take a time, which is within 1 standard deviation. Well, it's binomial. Okay. Why is it binomial? Well, do we have a fixed number of trials? Yes. Do we have 2 possible outcomes? Well, the probability of lasting more than whatever says there says more than 7 take a time, which is 1 standard deviation from the mean. More than that particular time, more than 7 take a time, which is within. So it's within those 2 time frames I stated. That's the probability. 0.6826 is the probability of it taking it, and Q is going to be 1 minus that. And then the probability doesn't change from calls to calls. We maintain consistency in the probabilities. So this is effectively a binomial distribution where we're doing the probability of more than 7. So it's probability of 8 plus the probability of 9. So that's going to equal the probability of more than 7. And so now we have 8, 9C8. And then you have 0.6. So we got 0.6826 raised to the 8th power. And then we got 1 1 minus 0.6826, which is 0.3174. 0.3174. And it's to the first. And then we add it to 9C9.6826 to the ninth. 0.3174 to the 0. And that's a binomial distribution. And so they compute this here. Now they don't write 9C9 here, but they're supposed to. But what's 9C9? 1. What's 9C8? 9. And that's it. And they didn't write 0.3174 here to the 0 because anything raised to the 0 power is 1. Now the question, so can you realize that that was binomial? Can you remember what the binomial formula is? The binomial formula is in the cheat sheet. I didn't bring it to you today. I gotta go by the mail office to see that they print it out. And now we gotta do it here in the spring. Will be 9. Okay, when you do it on your calculator, it says so. But if I were to do it here, okay, so look, 9 NCR is n factorial divided by n minus r factorial times r factorial. So 9C8 is 9 factorial divided by 9 minus 8 factorial times 8 factorial, which in turn is 9 factorial divided by 8 factorial times 1 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times, I know you don't see it, but I'm gonna go ahead and slide it to the left. What? If you want to, yes. Let me see your calculator, but if you want to compute it by hand, it looks like, oh my gosh, se mueve esto. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 1. So what happens is all these cancel and you're left with 9. Okay. Let me see your calculator quickly. Let me go ahead and stop the share. And well, let me kill the meeting first. Stop.